Hello and welcome to PCMINR.com, and you're watching this video on important concepts of electrostatics for grade 12 by Sonal Gupta. And I believe and I feel that the harder I work, the more luck I seem to have. And in this video, we are going to learn about an electric dipole. Now, what is an electric dipole? So again, as the name suggests, dipole means two poles. Therefore, an electric dipole is nothing but a pair of equal and opposite charges. So it consists of two poles, obviously. So one is a positive and the other is a negative pole. So we have a plus q charge and minus q charge separated by a very small distance. Therefore, an electric dipole is a pair of equal and opposite charges, plus q and minus q, separated by a very small distance. So let's look at this diagram we can draw here. So we have a charge plus q here at a point A, and we have another charge minus q which is at the point B. Obviously the distance has to be very small, though we'll draw it here. It shows as a macroscopic view for you, but the charges are actually separated by a very small distance, and we call this distance say to be 2a. So 2a is the distance between these two equal and opposite charges. Then they constitute an electric dipole. Now, how can we measure the strength of this dipole? So we have a quantity called electric dipole moment. So dipole moment is something that measures the strength of an electric dipole, and we denote it as P, and it is equal to, you can find the strength of a dipole from what is the magnitude of charge and the distance between them, the distance of separation. So P is equal to Q times 2a. We are just considering the magnitude. So it's any charge times the distance 2a. That gives you the dipole moment. And from here, the unit comes out to be coulomb meter, right? So dipole moment, Q coulomb and meter for the distance. So dipole moment is coulomb meter, and the formula is Q times 2a. An important fact you need to know about an electric dipole is that though the total charge of the dipole is zero, right, because it's plus q and minus q, when you add it as a system on the whole, the total charge is zero, but the electric field of the dipole is not zero because they are separated by some distance. So if you find the electric field at any point which is, at different distances from plus q and minus q, definitely we will get the different values of the electric field, though the same magnitude of charges are producing it. So we say that the total charge of the dipole is zero, but the electric field of the dipole is not zero because the charges plus q and minus q are separated by some distance, and so the electric field due to them when added is not zero. I hope you understand the concept of an electric dipole and the dipole moment, and we are going to use this concept of dipole moment to find the electric field on the axial line of dipole and on the equatorial line of dipoles in our next videos. If you find this video helpful, please like us, subscribe us, and follow us on Instagram and Facebook at PCMINR.com. Thank you for watching.